Audio. So the first presentation is about Red Hat OpenShift. It will be done by me. Then, as we said this morning, the second one was supposed to be on vanilla JS, but due to a scheduling issue, it will be done instead.
So,
okay.
The first presentation.
Okay. Okay, sorry. So the second one will be done by Daniele Michelis instead on how to use GitLab effectively, I suppose. Okay. So I think for some of you it's the first time, right? So the idea of the Flash talk is just to say distribute knowledge on technologies we are using around the company, and that we think may be useful for other projects or just to make everyone aware of them in general. So the first one is on Red Hat OpenShift. Red Hat OpenShift is a platform as a service platform done by, hold on a second, okay, thanks. It's a platform as a service offering by Red Hat. It's actually both an open source project and a commercial offering from Red Hat as usual from them. So they usually have, their business is like to build open source solutions and then to sell support and let's say enterprise versions of them. I don't know how many of you are let's say knowledgeable about Docker containers. So I don't know. Does anyone not know what Docker container is? 1, 2, 3. Okay, basically. Okay. So traditionally speaking, you code your application in whatever IDE language you prefer. And then what you usually did was like I build a jar file, for example, in Java, and then I give it to the operation guy that deploys it on some kind of random machine somewhere in the universe with possibly a different hardware configuration, a software configuration, operating system version different, JDK version that is different from yours, and so on. And so everything goes to shit because the environment is different and nothing works at the first try. This is the usual, let's say, approach. First, let's say, step was to use hardware virtualization. So the operation guy actually builds a virtual machine based on a standard configuration, but it's still a virtual machine, meaning there is a, let's say, some amount of overhead on top because the CPU is virtualized, the memory is virtualized, the disk is virtualized, but you can also use, let's say, physical disks if you want. But there is, let's say, a big overhead in terms of CPU performance and memory performance, and also a big overhead in terms of space, because for each single application you want to build, if you go full out, you have to build a single virtual machine for them. So if your application is 3 megabytes, your virtual machine is like 22 gigabytes if you do a Windows Server installation, which sucks if you're a company because memory is cheap, but disk storage is not, at least right now. So they said, okay, but I mean, I have a Unix operating system, and I mean, I can try to isolate some components of the operating system so that each application sees its own isolated version of it, most notably the network stack and the disk stack, and also you can put quotas on top of CPU usage and memory usage, for example. So this is how basically containers become to be. The first notable implementation is LXC containers. That stands for Linux containers, I think, or something like that. And then basically people start building on top, and let's say the first usable solution is Docker containers. Basically you have a file, a plain text file where you describe your steps on how to build, package, and deploy. Let's say build steps to build and run your application in an isolated environment. So you start by saying, okay, starting from I don't know, basic Linux image with just a kernel and a shell, you download Java on it, and then you compile your application with Maven, and then you run java-jar of your application.jar. This is nice because now we have a reproducible system, so each build is basically self-contained, so you can take that image and run wherever you want, and you are sure that almost everything stays the same. So Google came by and said, okay, we are using like, I don't know, 100 or 1,000 microservices, each one running on top of a single Docker container, but maybe I want to have my backend talking with my database, which is talking with my front end, and I want to orchestrate them and maybe run some kind of load balancer on top, because I don't know, I have like 30,000 instances of my backend. If one fails over, I don't want to make everything crash. So they built some kind of orchestration tool on top, which is called Kubernetes. So Kubernetes is an open source project by Google that basically deals in orchestration and how to make containers on Docker talk with each other, on let's say, banalizing it a lot. Then Red Hat came by and say, oh, okay, Kubernetes is cool, but the UI sucks. So why don't we build some kind of user interface on top? And we work a little bit on the user experience and developer experience. So they basically took Kubernetes, they made some proprietary customizations on top. They basically extended the language of Kubernetes, added a nice web UI, and started building command line tools in order to make everyone able to use Kubernetes in a, let's say, more simple way and more enterprisey way, let's say, so that it's easier to maintain and so on. So basically, OpenShift is a big platform where you can manage, deploy, run, and orchestrate your microservices, and in general, also fat services, but let's say more in general, your containerized applications like databases and whatever you want. So, let's say, starting from a high-level point of view, the architecture is the following. You got some kind of master servers which coordinate everything, basically. You got some kind of nodes, which are called data nodes usually, where the applications actually run, and they are orchestrated by the masters. Then you got, I don't know, on the side you got your persistent storage, where disks, for example, for databases stay. You have your cloud infrastructure on the bottom, where you have maybe, I don't know, services like, you can have virtual machines where OpenShift is running, or you can have physical machines where OpenShift is running on, and on top you have your network layer with your usual TCP/IP stack, with it talks to the outside world. So there is some kind of network that is internal to the cluster, and then some kind of network that is external to the cluster where your customers can access your services, but just the services you want to expose to the world. Then you have the usual suspects that work on the cluster. You have your developer that develops the application and builds and deploys it, usually using some kind of version control. And the operation guy, whose job is just to maintain the infrastructure. So they do not deal anymore in trying to make your application run properly. This becomes the job of the developer to actually make a package of your application with all the dependencies and whatnot. They just deal in infrastructure issues and maybe major version upgrades of, for example, the Java virtual machine if they decide that Java 1.7 is no longer supported at all. So, which are the benefits of an OpenShift infrastructure? At least if we see what Red Hat is telling us, that each developer is able to self-service for himself some kind of portion of the cloud infrastructure or your servers where they can deploy whatever they want, usually with zero to minimal effort in terms of configuration, at least for the basic stuff. It's easy for the operation guy to scale it up. So for example, if I got 2 backend services but the load is too high, they can just theoretically push a button and then make it scale up to, I don't know, 50 containers, and also they can hook some kind of automated system to actually auto-scale up and down the number of containers. It's also nice for the automation point of view because everything, as we will see afterwards, can be automated on OpenShift. From the how to build the code to how to deploy, how to scale your application, and so on and so forth. So those are, let's say, the selling point of OpenShift. So the first step, if you want to use OpenShift, is to run it somewhere. There are 3 alternatives. You can just use the free offering from Red Hat of their commercial platform, but it is limited, as in 1 gigabyte of RAM, I think, and 1 or 2 CPU cores, so 1 CPU core, yeah, available. So you have, and I think some kind of disk space, but not too much, to be honest. This is free. You can just go to OpenShift.com and register your account using GitHub credentials, and you're set. The other solution is to actually buy some kind of servers infrastructure where you run it, but I think that's out of the question. And the third point is to actually start an OpenShift cluster on your local machine, because sometimes it's actually nice to have a replica of the cluster on your local machine, so you can develop something as close as possible to the target infrastructure. And let's say this was not as easy as it is now in the past, especially on Windows. On Linux it was much easier. But let's say in the last 3 to 6 months, you have just to download some kind of binary from the internet, which is called Minishift. for example, if you use Hyper-V, which is the standard Windows 8 and 10 virtualization solution, you just go to Hyper-V, create a virtual switch, so you can bridge the virtual network to the external world, because you want someone to also look at your containers. You open PowerShell.bin, you set an environment variable to tell, okay, this is the switch I want to use, because you may have more than one. You just type minishift starts, and after some kind of delay, usually 10 minutes, 15 minutes, you have your cluster running locally, and then you can just use the command line tools from Red Hat to actually do your development and deploys on your local cluster. So let's take a simple scenario. Here we are almost all Java developers building usually, let's say, self-executable jars or vars application. So either you just do java-jar my application.jar, or just deploy your application into some kind of servlet or servlet container application servlet. For this demo, I'm concentrating a lot on the microservices style of writing applications, so some kind of self-executable application in Java, usually done with Spring Boot, which is what we use a lot recently. So basically, what you do, you create a standard Java application, meaning that it's just a Maven application with Spring Boot configured on top. I will show you an example of it, github.com. So this is a standard Spring Boot application. You've got your POM file for Maven that says, okay, I'm doing a Spring Boot project that uses Java 1.8, that depends on the starter of Spring Boot for FreeMaker application. Nothing strange here, and it uses the Spring Boot Maven plugin to actually package the application into an executable jar. As you can see, there is nothing at all here. It's just your vanilla Java application. See, that's the standard Java code for a Spring Boot application. And now you say you have done all this. Let's say the application is 1,000 lines of code or whatever, and you want to deploy it on an OpenShift cluster. What you should do, or what you are supposed to do, is like you have to download the OpenShift command line tools, which is a binary you can download from the OpenShift origin GitHub repository. It should match the version of the OpenShift cluster you are targeting to deploy on. But let's say from experience, old versions usually work on newer version of the cluster, but not vice versa. You just log in on the cluster using the credentials that someone provided to you and the URL of the cluster. If you use minishift, once it starts, it will print out exactly what credentials you have to use and which is the IP address. You create a new project. A new project is just a container of multiple. Let's say a namespace. It's a space where multiple containers can work in isolation from the outside world. So it's basically just a big folder where you deploy your services and whatnot. So you create one or use the one that was provided to you by some kind of operation guy, and then you just do like OC, which is the command line tool, new app for new application. Then you paste the URL of your Git repository. And then you say, okay, using which base image, the one from Red Hat for OpenJDK 1.8 applications. What this will actually do is the following. The screenshot is too small, but we can do like this. Let's paint. Hopefully it works. So it will download the image from the internet on the cluster if it was not already there. Otherwise, it caches it. Okay, it finds to see that there is a Java application. It will build something for you. We will go in details, and then it says, okay, if you want to see the build, because it will actually build your application using Maven, you can just type this command to follow the build logs, because of course the build will run on the server and not your local machine. So let's say you have done this, and then you want to actually show it to someone else. So you want to expose this service you just built to the outside world. What you do is just to say, okay, it's basically saying, okay, OpenShift, please expose my service, which is usually done by typing svc dash the name of your application. And then after some kind of 30 seconds or 45 seconds, you can just go on the URL of your application online, and you will see it live on the internet. As we can see here, or here, yeah, that's better. So it's basically magic. I mean, if you don't know anything else, it's basically magic. But actually, behind the scenes, it's doing a lot of stuff for you. The idea of Redact is to actually make the life of the developer a lot easier, so that you don't have to do anything unless you don't do something that is a little bit different from the default, let's say. So the idea is that, at least for Java application, .NET Core applications, or Node.js application, they should just work. Meaning that you just say, this is my repository, this is the base image I want to use, just do your stuff and it will work. That's their idea. I mean, this is the theory. Then the theory and the practice is usually different. But let's say for standard application, it's actually that simple. So, what's happening behind the scenes? Behind the scenes, if you ask for OpenShift, all the stuff that is running on the cluster right now, we see there is a lot of stuff. We see stuff like this is called OC, stuff that is called builds, IS, DC, which is a little bit cryptic if you don't read the documentation. But let's say that from an high-level point of view, what OpenShift will do is, as first it will create the so-called build config, which we saw in the previous picture, something called BC. This is something that tells OpenShift how to build your application. It will contain stuff like where is the source code repository, which is the strategy that I have to build. Should I use an image? Should I use Docker? Just Docker build on the Docker file that you are providing to me. Which are the credentials to log into my code repository, because maybe it's not public, as usually it isn't. And then it will say, okay, and then after we are done, where you should push this image to. Meaning, remember, this is always Docker. So at the end, it will push your Docker, it will be the Docker image, and then push it to some kind of registry. OpenShift has an integrated Docker registry where it deploys all the Docker containers it built. The reference of the Docker image it builds is called the image stream on OpenShift. This is exactly the same as a Docker image on anywhere else. Then it will say, okay, now that I've got a build config and image string where to push my stuff to, I have to actually instantiate my configuration in order to run the build. So the build is just an instance of a build config that pushes to an image stream, usually running a specific checkout of my source repository, meaning that it will contain, for example, if you're using Git, the hash1 sum of the Git commit we are using, so that if you want to rerun that build, it will actually check out that code at that exact point in time, thanks to Git history and so on. So I've got my build, and then I have, if I want, I have to tell OpenShift how should I deploy my application. So I have to create some kind of configuration object. This is called the deployment config, or DC, which says to OpenShift, okay, after we are done the build, which is the desired state of the application at runtime, meaning that how many replicas should I have of my application? Should I proxy it to some kind of service? Should I put some kind of environment variables in my system? Because maybe I'm using environment variables to configure the, I don't know, the number of connections I should open to my JDBC database or so, or something like that. It also says stuff like, when should I deploy my application? Meaning that should I use a trigger, so when there is a new build, should I also deploy it, or should I just wait for someone to press the deploy button, and so on and so forth. So let's say that someone presses the deploy button or says, okay, please deploy. What OpenShift will do is take the deployment config, see which build it should take, and then just make it run on OpenShift in one or more containers. They are not called containers in the OpenShift world, they are called pod, but they are basically the same thing, just the naming that is different. It's just basically a Docker container running on some node somewhere in your cloud infrastructure. Then, as you said, in the deployment config, there was some concept of number of replicas, for example. So how many copies of my container should I run? In OpenShift instantiates another container whose job is just to say, okay, should I start a new pod? Should I destroy the old pod? What should I do? This is called the replication controller. It's just like some kind of hypervisor or supervisor that just manages the state of the application. Its job is to take the current state of the cluster and make it so that it matches whatever you described in your deployment config. On top of this, sometimes you want to have this application actually usable by other applications in your project. For example, I don't know, I've got to deploy some kind of database, maybe a MySQL database, and then I want to use it from some kind of backend service. Now, typically, what you did in the past was, okay, maybe I should hardcode in some kind of configuration file the host name of the service I'm going to use. OpenShift tries to be smart about it. Remember, their point of that was to make it as simple as possible. So their idea was, if you have a service that is called database, then you should also have a host name on the cluster that is local, an host name that is local to your project that is also called database. So that you can say in your JDBC configuration file that the JDBC URL is not 192.3.68. whatever, but it's just like database, and that's it. This makes it easier also to migrate the application between different projects, because maybe you got a project for the developed environment, then a project for the UAT environment, where maybe the version of the application is different, but the configuration stays the same. So if you move that container, it will, I mean, technically speaking, there should be another container that is always called database on the test environment where you can connect to, so that you don't have to make any changes, if possible, to your configuration. So this is the service. The service is basically just a combination of IP, port, hostname, and then a pointer to the set of pods issued proxy to. So it's basically a TCP proxy or something like that. At the end, sometimes you want to expose stuff to the internet, because I mean, I've got my nice website and then I want to show it to the world. So you have to route it to the outside world. Right now, until the service comes in, so including the services, everything is internal to the cluster. So no one from the outside can access your services. If you want to expose something to the outside world, you have to build what is called a route in the OpenShift world. A route, I mean, can be many things, but the most useful routes are the HTTP and the HTTPS ones that basically proxy a connection to a service using the HTTP protocol. This is the basic one. Also, sometimes it happens that you don't have, for example, an HTTPS service exposed internally in your cluster, but you want just to use HTTPS just when you talk to the outside world, just to, I don't know, for example, to avoid overhead internally or whatever. So another nice thing that OpenShift can do for you is just to do TLS termination, meaning that it can create the HTTPS connection until the edge of the cluster. So internally, it's all HTTP, which is better performing than HTTPS. But from the outside world, everything is HTTPS. So let's say this is basically the introduction on whatever is going on behind the scenes. We have seen the UI command line, the command line UI, but I mean the command line interface is usually boring, so people like to use web interface nowadays. And of course, Red Hat built also a web interface. For the purpose of this demo, we're going to use the installation that is done on DataGap server. Actually, the DataGap cluster is just one server running OpenShift, but that's not a big deal because you can always add more nodes at the end when you need them. So you log in. So what we haven't seen is the login. So basically, you connect to the cluster and then you have to do the login using the credential. The same credentials you have to use on the command line. So I will use my account here. You have to select the project you want to work on. For example, we are doing a testing project here. And here you have the dashboard. This is the, let's say, 1000 miles overview of whatever is going on your cluster. So you can see all the services, maybe grouped logically, that are running. For example, we got CART web application. We got .NET web application running using .NET and ASP.NET on .NET Core. We got our nice Spring Boot demo application that is running on OpenShift. And we got some kind of Jenkins server for continuous integration and continuous deployment. Another nice thing of OpenShift is that it can actually detect if there is some kind of Jenkins configuration file in your source code repository. And for those of you that have used Jenkins, it can actually create for you a pipeline that says, okay, I should build the code, test it, build the image, and deploy it on the OpenShift cluster. So, I mean, for those of you that know Jenkins, this is actually something that is handy. Yeah, indeed. So this is the overview of the cluster. Then we can browse all the stuff that's going on in the cluster. For example, we can check, I don't know, all the builds that we have done. Let's say that, for example, for the, okay, let's check the deploys actually. So I'll show you something with you. Nice. So let's say that the customer is calling, screaming that, oh no, your last deployment of your cart application sucks, which actually happened to Amazon some days ago. So there is a bug, and we actually have to run and roll back to a previous version of the deploy. Since everything in OpenShift is built so that it is, let's say, self-consistent and immutable, we can actually run roll back on an older version. For example, if I take the cart application, we can pick an older deploy, let's say, and we just press roll back. Okay, it will ask if you have just to roll back the application and also the configuration stuff. We'll just go for the configuration for the application itself. So we ask for a rollback, and if you go back to the deployment, we will see that there is a new deployment pending. It is actually taking the old image that was built and deploying it on the cluster and replacing the old one with this. So let's say now it's done, I suppose. And we can also check the logs, for example, if you want. So those are the log of the deploy. If we can check also the log of the pod here. So as you can see, it's running. It's starting up a standard Java application using Java 1.8. Another nice thing is maybe your application is so cool that you have too many people hammering on it. So you have to actually scale it up, maybe across multiple servers if you have many of those available on OpenShift. So let's say I've got my nice .NET application. And so I can just say, okay, now give me 4 copies of it. So what OpenShift will do is actually start, if you go from the monitoring overview, it will start three new containers, all running the same image. As you can see here, it's the same version of the image. And then it will proxy all of them behind the same service. So there will be some kind of load balancer using an HA proxy, and it will serve the software from using probably some kind of round-robin policy. So let's see. Okay, now it's starting, and now we have, if you go back to the overview page, you can see that for the .NET application, now we got 4 pods, 1 running, now 2, and 2 that are not 3D. So after a while, we should see all of 4 of them running. And that's the application that Luca showed us last time. So as you can see, you're not locked in on some kind of technology. The point is, as long as it can be the Docker image, it can be deployed on the OpenShift cluster. Meaning that if I go back to some kind of project we're doing internally on Polaris, this is some kind of complex project. We got a lot of stuff going on. We got some backend microservices running in Java. Maybe they are using some kind of database. This time they're using MariaDB, which is basically MySQL. Some kind of queue manager for JMS, which is ActiveMQ. We got front-end applications running, like the front-end, for example, which is built on top of Angular and Node.js. We got infrastructure services running, like an instance of a Nexus repository to store the artifacts and avoid hitting the network every time you have to do a new build, because that's costly. Or, for example, you can use it to serve to the whole company services that are useful to everyone, like some kind of SonarQube instance to run the analysis of the code or the quality of your code. So this is just a Java application that is using a lot of stuff, a database, and also internally some kind of analysis engine. You just deploy it in OpenShift, you tweak the configuration a little bit because it's not native, let's say. But after a couple of days, you have it up and running, and then everyone else can log into the application. As you can see, it's running in HTTPS. As I was saying before, the TLS termination is done by OpenShift because SonarQube natively doesn't support HTTPS, but that's not a big deal because the reverse proxy is the OpenShift reverse proxy does it for you. If you go to the route, so we can see that, for example, for this one, if I look at the configuration, here is the SSL certificate that OpenShift is using. As you can see, everything else is also highly usable from the web interface. Basically, everything is exposed, also the storage and so on and so forth. Of course, Red Hat says that you should do most of the stuff via the CLI interface because it's actually more flexible than the web UI. But from my point of view, I mean, if you have to do standard stuff like start a new deploy, roll back to an older version of the deploy, it's actually easier to do it from the web UI than to use the command line interface. So that's OpenShift for you. I mean, I know it's not easy to start with it, but I mean, for the gap at least we've got an instance running here for free, basically. So we all do Java application. Sometimes it's actually useful to use it. For example, if you have to show some kind of demos to your client, just stuff it on OpenShift, create a new project, run the application, then your client just has URL where they can go to, and that's it. Assuming you don't have to use any kind of resources from your client's network, that's it. Yeah, the takeaway is that it's really something that is, at least for me, I found it highly useful in Polaris, because we got, at one point in time we were doing like, I don't know how many builds per day, because we confused that such that every time you push on the master branch of the repository, it was running off a build of all the services, and it was deploying everything. So you can just go online and show to, I don't know, Claudio or whatever, the latest version of the code. Then when you are stable, just usually disable the auto deploy feature and just run deploys on demand after you run some kind of smoke tests, maybe internally, or using the pipelines of OpenShift. So that's all. Thanks for joining the presentation. If you have any questions, I don't know how much it took for me to do it. A little bit more than expected. Okay, sorry. Okay, that's it. Any questions? Anything? No. Nice. Okay.
Just one. I see the OpenShift console itself is not under HTTPS.
No, it's actually HTTPS. It's just that we didn't bother using
okay, so it
a proper certificate.
It can proxy itself under HTTPS.
Correct.
Okay.
Yeah. It's always HTTPS. I don't think you can disable it actually. It will just start up with a self-signed certificate and it will complain. But
Okay, so
I mean, we don't care. It's not exposed to anyone else.
yeah, but if I want to run my own OpenShift, I can give it a certificate.
Correct. You just have, during the installation process, you have to configure it. The only point is that OpenShift likes to take the port 80 on your cluster, meaning that you cannot have anything running on port 80 and 443. And I mean, the web UI port is probably configurable, I don't know, but it's running on 8443. So the point is that you run OpenShift on a dedicated cluster because it takes possession of everything. Just don't run anything else on it because it just creates just a bad experience for everyone. That's the way.
I have to configure the certificate at the install time. I can't change it after.
Not from the web UI. You have some kind of configuration stuff to touch around in the on the server and restart everything and hope that it works. You have also to push the certificate over to all the nodes because it's the same certificate used for inter-cluster communication. Okay.
I have a question, Giovanni. Which is, for instance, the domain name of Polaris in this case?
So the domain name is composed of the service name, the project name. So by default, at least, it's composed by service name dash project name dot the cluster, what is called the cluster DNS prefix, which is OpenShift.tech.it. So for example, on Polaris, this is the admin panel service of the Polaris project. So it's admin panel -polaris.openshift.deget.it. But you can go to the route and just change the DNS to something else, the host name to something else. Maybe because you are serving a service out and you just point to the DNS record to this machine and it works.
But so that this means that there is a DNS running.
Yeah, there are two. I mean, there is one DNS running on OpenShift, which is the cluster DNS, which makes so that all the nodes of the cluster can access the services using the host name. Then the cluster is basically just saying, okay, which is the host name of my request using the proxy. Is there a service running on this project for this host name? Yes, and it just forwards it. So the DNS that is running on OpenShift is not exposed externally. You just have it's just using the HTTP proxy to see the host name either or the HTTP proxy to see which service should it go to.
Okay, so you have to configure your DNS server.
You have to,
provider.
and indeed you have to use a wildcard. I mean, it just serves from a point on. So that's the standard DNS stuff. But yes, and it takes the complete
Oh, yeah, so
host name.
if I use, for instance, not Cloudflare as my DNS provider, I can just do the wildcard and then all the
I think
all the
so.
subdomain.
I think so.
Yeah.
I hope so at least. Okay. Okay, thanks.